Hey everyone, so here we're going to do a simulation that deals with constructing confidence intervals for a mean when sigma is known. Okay, so here we're going to, in this region right here, we're going to see the confidence interval being created with our parameters here. So note that our mean is 10, our population standard deviation is 2, and we'll deal with sample size of 100 so that we can accurately describe these confidence intervals. Again, central limit theorem has to apply. Okay. Over here we'll see the most recent sample of outcomes and then the sample mean plotted here. But really we want to concentrate on this right here. Okay. So let's go ahead and start our, again, this is for a 95% confidence interval. All right, so let's say we take one interval. We create one interval at random. Notice that the interval is here, represented by this little green bar. Note that the mean, the true mean of the population is 10. The sample mean was a little less than 10, 9.937. But our interval trapped the actual population mean here. So we were successful when creating our confidence interval. Okay? Let's do it again. Here we do another sample. We get a similar result here. The mean is a little less, 9.87 from our sample. And we actually went and trapped the... Excuse me. We actually trapped the true population mean, which is 10, within our interval, okay? So now let's start making more and more intervals. So let's do, let's do 10 intervals, okay? All right, so you can see here that we have 10 of our intervals. All of these little black dots represent the sample mean, so none of them quite are 10. Maybe that one's right at 10. But we can see here that when we sampled with size 100 from this population, that all of our confidence intervals are meeting that criteria by trapping the true population parameter, which is 10 for our mean. Let's do it again. You can see we hit it again, all 10. Let's do 100. All right, so now we have 100 confidence intervals that we've just created. You can see that many of them have trapped the true population parameter, true population mean of 10. There are these red ones, however, now. So you can see that some of the confidence intervals did not achieve that by trapping the mean, population mean, within the interval. So here the interval is outside of that. It doesn't contain 10, okay? So there is some error that evolves with our level of confidence. If we continue to do that, you can see here, a lot of them do work for us, but those red ones do not. So let's do, let's say 1,000. 1,000. So here we have a lot of good ones. You can see that the sample means, of course, are normally distributed, but they should be, based on the central limit theorem. But you can start to see a trend overall. So the intervals containing mu out of these 1,000 is about 93.9%, very close to 95. And then here we have a running total of 93.7. All right. I'm going to take a bunch of samples and keep your eye on the running total. Okay. So after many confidence intervals are created, we see that about 95% of them trap the true population mean within the interval. Okay, so here we've taken 69,200 confidence intervals, created them from our samples, and that's what we get, 95.1% of those intervals. will contain the true population mean. So this is what we are talking about when we deal with level of confidence. So only about 5% of all of them will not contain the true population mean.